Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. First of all, thank you for the opportunity given to us. We are team PBL TRPL-403 and in this video, we will present our project titled Smart Attendance System using Multi-Device IoT Integration, or as we call it, TIKA. Before we dive into the details, let me introduce our team. My name is Veny Isnaini Prastia, serving as the moderator and tester. Then we have Whelmyran Bima Adhienirma as our leader and business analyst, Muhammad Jauharil Musthofa as back-end developer, Andri Putra Desyandra Siregar as designer, Fito Desta Fabiansah as mechanic engineer, and the last one, Jeremiatur Hamonangan as front-end developer. Now, let's move on to the general structure of TIKA. First, let's look at our objective. We have 5 main goals. There are enhanced data integrity, ensure system reliability, provide real-time recording, guarantee reporting accuracy, and improve management efficiency. Then the problems that inspired this project are attendance fraud, system unreliability, physical constraints, delayed recording, and the last one is inaccurate reporting. For the next slide, it's about product benefit and feature. We'll continue by Jauharil.
Thank you, Veny. For the benefit and features of our product, the first one will be multi-level user management. So both the admin and the organization can manage its own users. And then multi-level authentication system. Our devices will feature RFID, fingerprint, QR code, face recognition, and for our multi-authentication system. And then real-time web monitoring dashboard, which can be used to view the attendance data of the members or your own attendance data. And then offline data buffering. So if the device is cut off from the internet, it will be able to store the attendance data in an SD card before being sent to the server again once the device is connected to the internet. Then attendance report can be exported to formats such as PDF or Excel. And then for the benefit of our product, the first one being our system will be secure with structured access control. So different users will have different roles. Members can access organization data, and etc. Second, reduces fraud. It will reduce fraud and improve the accuracy of member attendance. And then it will be transparent, and the monitoring will be in real time. And then the system will be reliable and the data shall be continuous. And then it should simplify the reporting process of user attendance. Next will be the flowchart by Jeremiatur.
Okay, this is our flowchart system. It allows users to select an attendance method like QR code, RFID, face recognition, or fingerprint. Then verifies the data by matching it against the database via an MQTT broker. Send the attendance data if an internet connection is available and send a success notification via WhatsApp. If there is no internet connection, the data is stored on an SD card and sent once connection become available. The next is explained by Fito.
The next is design and equipment scheme. In this scheme, we can see that our component is connect to the ESP32 via expansion board 38 pin, and the component that we will use is TFT LCD as the monitor or display, SD card reader as the local storage, RFID card reader, ESP32 cam as the camera, ESP32 as the microcontroller, fingerprint sensor AS608, MAX 98357A as the amplifier, button to reset and switch the mode to the face recognizing and QR code attendance, and then the speaker. Next, this is our system connection diagram. In the first, if the user is using face recognizing as their attendance, the data of their attendance will matching into the database via backend API face recognizing, and then the data of their attendance will send into the backend API via MQTT through the MQTT broker, and then the data will store into the database or send into the website, and then the user can retrieve their notification of their attendance via WhatsApp chatbot. Next will explained by Andri.
So next is the specification and operation of our device, which as we can see at the picture, there are three main process. The first process is the input or identification, which on our system we can the users can authentication with four method. The first one is face recognition using ESP32K module to capture visual image, and RFID card authentication using RT522. For the fingerprint biometric authentication using I608 and QR code that can be generated on the website. For the second main process is on the device, which is ESP32 as a main controller responsible for data processing and communication with the server. TFT display to give status information, speaker for the sound notification, and push button is for activate the face recognition and reset configuration. And micro SD card for stores attendance data locally before sending it to the server. So if there are any network interruption, the attendance data will not be lost. And the last process is on the server on database. The attendance data will be stored on database MySQL, and the data will be displayed on the website. Next, please. So this is our progress implementation for the website. This is the implementation of the design. Currently, the user interface development is focusing on core functionality and light consistency. So it's not 100% same as a Figma. So the status is still in progress. Progress detail is 7 out of 17 pages have been drawn. For the next presentation will be explained by Bima.
This is our hardware and system integrations with the core hardware and backend is fully functional. We have successfully implemented a connectivity, a stable MQTT to API to website data pipelines with Wi-Fi manager, authentication, functional RFID and fingerprint scannings, management remote member enrollment system and live attendance logging. The core logics is a full support for organizations, registrations, and member management. Current work and implementation is our current focus is on data redundancy and advanced biometrics. We are moving from direct API calls to an SD card buffering system for offline reliability. Additionally, face recognition implemented is next in our development queue. Next is artificial implementations. Currently is not yet implemented, but the system is first the training phase. The system collects face image and extract unique feature. These are converted into numerical data called embeddings using a convolutional neural network or a CNN, and then stored in our database. Second, the recognition phase. When a new face is captured by the camera, the system extracts its feature in a real time and compares them against our database. If the similarity score exceeds our set threshold, the person is successfully identified.
And then for our project, our project will contribute to the courses such as follows. For calculus, we will provide mathematical foundation through the TIKA system through concepts such as functions, matrices, sequences, limits, and support data processing, and also system modeling and performance analysis. For artificial intelligence, we will implement artificial intelligence through our face recognition feature, and then in software maintenance, we will be supporting our software for its deployment, monitoring, security, and cloud implementation. For software security, we will be using secure SDLC principles by integrating it from the early stages all the way through its deployment stages. For hardware programming, we will be using the knowledge provided by the course to develop hardware interfaces. For general English, we will be contributing to it by using communication and professional report writing in English. And for the IoT application development project course, we will be contribute to that course by supporting structured IoT projects, but with development planning, risk control, progress monitoring, and effective teamwork.
That concludes our presentation of TIKA. We apologize for our mistake and thank you very much for the attention. Wassalamualaikum warahmatullahi wabarakatuh.